Hi, this is Corbett Lunsford, founder of the Building Performance Workshop. I am in love right now. I'm in a training center that was built by Michael Dunseith of the Green Jobs Training Center. You can see his poster right behind me. He's going to give us a tour of the most amazing home performance training center I've ever seen in my life. So we're in New York City right now. We're right next to JFK Airport. If you happen to be flying in, you can go ahead and give him a call. And let's go ahead and meet Michael. Michael, thank you for showing us around your excellent training center here. So what exactly, first of all, how big is this place?
It's just over 2,000 square foot.
Okay, and how long have you been in here?
Just about 2 years now.
Okay, and as I understand it, you built every single thing that we're about to see.
I designed them and built them myself.
Or bought it or scavenged it, but you assembled basically the entire place.
The props and the mock-ups, yes.
Okay, and that is because you have decades of building experience.
That's correct.
Okay, cool. So let's go ahead and just get started. Start us out nice and easy. How about this gigantic house that's in the middle of your training center? Okay, what do we have here?
This is my newest project. We call this the float. So the reason it's the float, it simulates something you'd see in the Macy's Day Parade being pulled along. Okay. It is on wheels, so we're able to move it around. The goal here was for air sealing training up in an attic. Some of the current trainings, they use desktop mock-ups and things like that. So in the real world, we have to work up in an attic. I wanted the students to get the understanding of the real world, that you can't step on a sheetrock, you would damage the ceiling area, so they'd have to work on top of the ceiling joist. This prop here is capable of being pressurized. So what they would go around and for example, seal the ducts around the registers or our hi-hats. After they've been working up here on the attic, not on a flat floor, on the attic, they would seal these props. What we would then do is pressurize the system with smoke. If the smoke leaks, they didn't do a good job.
Nice.
So I'm currently working on this. This is my second prototype. The first one, I didn't quite like the results, but I was very happy with how it worked out. So the visual aid of actually seeing what would happen in stack effect. So the top plates, exterior top plates, electrical outlets, attic hatches, and things like that.
And are you able to make it 130 degrees on the top of this platform?
We're working on that. We're going to put a heater in there and then tarp over this to actually change the climate a little bit. And then the bottom area will simulate a confined crawl space.
Wow.
So for the new students that are maybe uncomfortable in dark areas and tight corners, we could quickly ascertain if this is the career path for them.
Who's your spider supplier?
We do use those fake spiders from Halloween displays and the cobwebby things to give them the feeling. Although I haven't quite simulated rock, dirt, ground floor, but one thing at a time.
Awesome, I like it. And up here, it looks like you've got now you rent this place, right?
Correct.
Okay. Now, did you tell your landlord what you were going to do to this?
He was very conducive to feel free to do whatever you want.
Okay, cool. So right here, you have basically exposed the entire HVAC system. Did you install that HVAC system?
It was a existing system that we renovated to apply for building science.
Huh.
Some of it's good, some of it's bad. It works for duct diagnostics and techniques and training.
Okay, cool. And then we've got some more hands-on props where we can actually do dense packing in this room.
Well, we have our cool machine. So we actually do low cellulose here.
Okay.
We have simulated walls. Over here, one of our props, plexiglass, the students could actually see how the walls dense pack within it. So
can you show us now you're, first of all, huge props to the guys who actually designed the props for the BPI and the MRL trainings, which I understand you actually designed the MRL window and door prop, which we'll see in a second. But this, if you are a trainer or if you've been through an air sealing class, this wall is put together and held together by these safety catches instead of by simple screws, which take a million years to get apart. This thing is going to fly apart in about 2 seconds, so I think that's excellent.
So, yeah, we have our release. This opens up, and then the front slides
Amazing. So if you need air sealing props, you know who to hire to build you the best ones that you can possibly get. All right. This is where you keep all the rest of your materials?
Yep, so
this is
inventory back here, whether it's sheetrock, foam boards, and things like that, so when we do our air sealing classes. One of my other props is our cantilever. In houses, we have a lot of times overhangs, area of weakness, pressure and thermal boundaries. This has been made to simulate a balloon frame wall, so this cantilever is connected to the stud cavity. So we don't want to lose our cellulose down into this area, so we use the onion bag trick.
Wow.
So we're going to dense pack this area. So this is all accessible. All the glass opens up and you can see exactly how it creates a plug up in here.
You know, I think that the fact that you are in New York City is very important to your approach, because this is basically the IKEA of home performance. I feel like you've used space efficiency to an insane level at this place. So this is one of the MRL props that BPI
one of the new pilot programs, right?
Yeah.
So they have to install a door and a window.
Okay.
When this is fully assembled, it would then flip down and represent the attic floor for an open blow for the crew installer for the new DOE's MRL exams.
Yeah. Okay.
We have another dense back wall here, simulated mock-up of a rim joist, some ductwork, lots of bathroom fans for our new ASHRAE standards and building airflow.
Wow.
So we can rig these up, or these could be dropped down. We could hook up long lines and tie knots in them and show how airflow is restricted. Different types of insulation when we get into our envelope professional and the pros and cons of insulation, the values, the thermal properties or vapor properties, sound acoustical properties. So that we do have a high performance window here. This is more on the passive house or net zero energy, triple pane.
Where is that from?
This is Germany.
Nice. Okay.
A little expensive. I was able to pick this up leftover from a job. Very nice, but it different. It will tilt in or come in double sealed, so it meets the air tightness levels and everything like that.
Wow.
Little on the fancy end, not quite what we normally see in home performance. But,
Sure.
So we go from the the basic single pane, or I have double pane aluminum, double pane vinyl, triple pane wood, to demonstrate all the different types of.
And right behind you, we've got another section of a roof.
Yeah, we're working on my roof line here. So mechanical ventilation, which is hooked to another bathroom fan underneath. We're working on our mock-ups here, which demonstrate different attic ventilation and soffits, whether it's rectangle, round, or etc. This open area here is going to be plexiglassed with wind baffles.
Wow.
Different display of our minimized wind washing effect. On the other side there, you can see a roof line peel away, drip edges, ice and water shield, shingles.
Now, you've mentioned that actually building a house would be easier than this because you're trying so hard to actually show how the thing is built. But that takes most of the time, is defining the curves that you need to cut away.
The imagery of the peel away, so that you could actually see where the flashing will roll up the side wall, and then the step flashing, and how the siding overlaps tie-back or outside insulation, and simulated brick. So a lot of time's gone into it and tweaking it. And yeah, probably a lot easier just to build a house than to.
Yeah. And here again, we've got more cutaways of siding. Awesome. What's in the next room? You got mechanical stuff too, right?
Yes. So we get into some of our heating equipment, from the high-tech electric heat pump hot water heaters. This is a oil-fired system, so we're trying to get this to be an operating system. We haven't quite worked out all the bugs on that yet. But
you were describing, you were literally just going to put the flue out the window.
We want to bring it into the main room so that we can put a glass around it and actually see this operate and fire. So
awesome.
We're working on that. Kind of new, not quite as common as what you would see, but this is sort of a conventional hot water tank, but this has a concentric vent pipe. And on the back side here, you can see its intake. So this is a sort of a sealed combustion atmospheric appliance. We're trying home performance. We know that we tighten up houses. We don't like atmospheric appliances.
And
so this takes it to the next level.
Yeah, I'm from Chicago, and I've never seen that before, so that's a new one for me. I think that's very exciting.
So yeah, a simulated basement area with our stone walls and another basement rim joist area, some fake plumbing in the background. Our cutaway of our gas-fired hydronic system.
And everything in here is on wheels, so you can just put it away whenever you're done with it. I think that's amazing.
This has the full system, the zones right up to the baseboard heating.
Awesome. Great.
Our insulated basement wall system. So
the right
simulated
way.
Concrete foundation. Formula, extruded styrene. Furring strips that allow you to fasten your sheetrock to. This provides an R5 and 7.5. to our basement wall assembly. Minimizes that air gap or wood framing process. Vapor barrier, thermal barrier, air barrier, line continuous. Excellent finish for a wall assembly for basements.
Excellent.
Recently our area was rocked with sandy, so we have a lot of people are renovating, so hopefully they're taking advantage of the opportunity to renovate vapor barriers properly placed.
And we're on the second floor here, so luckily the water line didn't come all the way up.
We were lucky.
Yeah.
Over here we have our thermal trainers. So this is actually picked up from upstate New York, a company, Sundog Solar. They designed, put this unit together. Evacuated tubes or flat panel. This is actually 2 systems.
Does it actually work?
These are functioning systems.
Amazing. All right.
Over here, some more displays. Obviously, some of the more industry recognized equipment, Retrotech, Minneapolis Blower Door, Energy Conservatory, Mitsubishi heat pump, split system, seems to be very popular these days.
Now, one of the things that I'd just like to point out is that Michael's so attentive to what his students need that he has actually painted red the letters on the rings for the blower door. If you have been through a blower door training, I bet you $100 that you've never seen that done. I think that's a brilliant touch. It's all the little details that I'm really crazy about here.
And the range. So,
Awesome.
6,300 to 24 on the open.
Because, of
Your
course,
A-ring.
the manufacturer couldn't put that on there themselves. That would be too crazy.
We want our students to understand that there are flow ranges for this equipment.
Yep.
Some
Genius.
displays of dryer vents, air sealing, recessed lighting, which we know is a major problem of the attics.
We have another cutaway up here with you're demonstrating a drop soffit fix.
Well, this is simulating the exterior front door of a house. So we have siding here, typical tar paper from the older housing stock, sheathing underneath. We have an overhang here, which will be a cantilever for a second floor. Sometimes recessed lighting up on the exteriors. We know this is always a weak spot for pressure and thermal boundary. So I kind of cut it away, and you can see the studding up top, standard insulation. Probably installed a little too nicely from what we're used to seeing. Probably she should have compressed and left some gaps up in there, but so just sort of an image of an exterior house.
Now we've got, it looks like an attic access up there. Is that truly a small attic?
Well, if I take you into the other side, I could show you a better attic. And I'll let you stick your head up there and poke around a little bit.
And you made this attic too. This obviously was not here to start with.
We're in a 100-year-old building, so it's got a flat roof.
Got all kinds of different insulation up here. The spray foam. You put knob and tube wiring in here.
That's correct.
That's great.
We tend to have older housing stock, and some of our knob and tube is still out there, so we want students to be able to recognize.
We have air leakage. We've got recessed lighting. We've got duct boots. We've got top plates.
If you pull your fiberglass back, you'll notice that there's a drop-down soffit.
Wah, wah. Drop soffit underneath a bat. Classic. The amount of attention to detail here is astonishing. We've got our stove that we can test.
Our first combustion safety testing is started here. Domestic hot water heater. We talk about different parts, insulating pipes, how to set the temperature, parts and components of it, what people you might find inside, baffles or heat exchangers.
Nice.
So a lot of people see the outside, they don't quite understand how the heat bounces around in our flue pipes. And of course, we're always right prepared, our manometer. So we need to do our baseline measurements. So it just so happens to be outside already. So we're prepared for our measurements, our draft measurements, multiple holes, depending on where they want to go. And then we're able to manipulate this CAS for the CAS depressurization, whether we want to keep it within the limits or exceed the limits. We can make it spill. The other day, somebody challenged me with carbon monoxide, so we pushed it to 4,000.
Wow.
Our brand new testo.
Was that with a hot dog on the heat exchanger, or what exactly?
No, we just plugged up the air intake. And our testo worked magnificently. Was able to shut down at its target mark of 4,000 to save the sensor. So they were quite impressed. Obviously, we were monitoring ambient CO, and we're still in a safe zone, but we'd like to show students what potentially could happen.
In real life, yeah.
Right. So all these appliances and everything is we could go the full range, from intolerances to exceed tolerances, and put on a nice show.
Awesome. And of course, we've got wall hangings that are very apropos to the subject matter. You got a little bathroom in here as well, and I like the shower touch specifically.
Well, of course, motion sensor lighting, an opportunity for base load reduction. People forget to turn the lights off. Dad's been screaming for years, turn the lights off. So hopefully nowadays, pretty soon somebody's going to have an app, you can turn the light off. But mechanical ventilation, which is an important part of building science, following the new ASHRAE standards, that testing and measuring and verifying this. So all that's been taken into account. Water conservation opportunities, big important thing, saving the planet. So we have a simulated shower here with what I would try to get is the large garbage can type flow hoods, the waterfall.
Does that actually work?
No.
Okay, good. At least there's that.
But it was the visual impression that it was this huge head that would put out a lot of water. But we want students to be able to acknowledge that there are ways to measure the flow rate or look for the measurement that make recommendations for the homeowner.
Amazing. Cool. Well, I am going to go back and look at my training center very differently now. I hope that you have enjoyed seeing this tour, and I hope that if you are in New York, you definitely give Michael Dunseith a call at Green Jobs Training Center. I'm Corbett Lunsford from Building Performance Workshop. Tune in next time.